Part of the whole conservation process, we're taking this as an opportunity to look at all the sort of analysis and documentation we can of the Magna Carta. So we've got a series of experts coming in. So we're looking at basically all elements of the Magna Carta that we can assess in this way.
I'm here to do some inorganic analysis on the Magna Carta. So it's a non-destructive analytical technique that looks at the inorganic components of the object. So it just takes a reading from the surface of the work and then X-rays are admitted from the instrument, and each element that's present has its own characteristic sort of fingerprint, I suppose you could say, and that allows us to identify what's there in the sample. There's a lot of calcium in the parchment, which relates to the liming process. But yeah, we have found iron in the green. And then no elements in the seal, in the wax seal, so it's an unpigmented material.
Many people are probably familiar with a laser scanner. So the equipment we're using is actually a white light scanner. So it means that it's completely conservation safe, it's eye safe. And what it does is very quickly project stripes and grids of light on the object, and then basically the computer software stitches that back together and derives a three-dimensional point cloud. So if an object is worn or damaged, then it's possible to bring it back to its original shape. If necessary, you could reproduce the object. So 3D printing is becoming much more popular. You can buy them in stationery supply shops. So if necessary, they could be reproduced. It's possible to almost reproduce them in the materials that they were originally made with.
Microfading is a means of exposing an object, a coloured object, to a great deal of light in a very short time. And in 10 or 20 minutes it replicates the kind of fading that an object might be exposed to in 7 to 10 years of real exposure in a museum, or in this case in Parliament House itself. Iron gall ink is a compound that's quite similar in many ways to another pigment called Prussian blue, which if you expose it to large amounts of light will fade, and then if you leave it overnight, for example blueprints, it'll revert back to the original colour. Most colorants, most dyes undergo photooxidation, so you need oxygen and light to make them change colour, and usually that photooxidation is permanent. But as it turns out, iron gall ink is rather like Prussian blue in that it undergoes photoreduction, and that at the same time as it's losing colour because of photoreduction, it's regaining the colour dynamically through oxidation in air. That means it's pointless putting it in an environment without oxygen in order to stop it fading, because in fact oxygen is the friend of the ink, not the enemy in this respect. However, I should say that other parts of the document, like the parchment and the silk, they will undergo oxidation. So you've got an inherent conflict here. One part of the document probably should be exposed to oxygen, and another part of the document, it would be better if it wasn't exposed to oxygen.